Hello everyone, welcome back to my channel Learn with Simran. In today's video, we are going to talk about cross-validation techniques in machine learning. So if you have ever built a machine learning model, you would have some idea that we split our dataset into two parts, the training data and the testing data. The training data is used to help train our model, while the testing data is used to see how our model performs for the new unseen data. And the cross-validation technique is used to help split our data set. So let's not delay it further and see what are different types of techniques available to split our data set. So let us start by understanding what cross-validation is. Cross-validation is a technique used to assess how well a machine learning model will perform on unseen data. It's one of the key methods to prevent overfitting, which occurs when a model learns too much from the training data and fails to generalize well. So why is cross-validation so important? Well, it provides us with a more reliable estimate of model's performance compared to a simple train test split. It helps us tune hyperparameters, evaluate multiple models, and ensures that our results aren't dependent on just one train test division. It is a critical step in the machine learning workflow. There are several types of cross-validation techniques, each suited for different scenarios. The most popular ones we will discuss today are leave one out cross-validation, K-fold cross-validation, stratified K-fold cross-validation, hold out cross-validation, and time series cross-validation. Let's break down each one of this technique one by one. So first up is leave one out cross-validation. Here we treat each data point as a validation set and train the model on the rest of the data set. It is great for maximizing the training data, especially for small data sets. However, it can be very slow for large data sets because we need to train the model n times, where n is the number of data points. The computational cost is the main drawback here. In case if you want to see how to implement this on Python using sklearn library, the step-by-step algorithm is on the screen. Now let us move forward with K-fold cross-validation technique. One of the most widely used techniques, the dataset is split into k equal parts or folds. We train the model k times, each time leaving one fold out as the validation set and using the remaining k minus 1 folds for training. It gives a balanced estimate of the model performance and is generally faster than the leave one out cross validation. In case if you want to, and the Python algorithm can be seen on the screen. Now let us move with stratified K-fold cross validation. When dealing with imbalanced data sets where one class may dominate, stratified K-fold cross validation comes into play. This technique works similar to K-fold but ensures that each fold has the same proportion of classes as the full dataset. It's a bit more complex but it is essential when working with classification problems where class imbalance could distort your model's performance. So here's the Python script for stratified K-fold cross-validation. It's very simple to implement in Python as of other cross-validation techniques. Now let us move with hold out cross validation, which is probably the simplest method. Here we split the dataset into two parts, typically 80% for the training and 20% for the validation. While this method is fast and easy to implement, it does not always give the most reliable results since the split may not represent the full variability of the data. Still, it's a good quick check method, especially for large datasets. And here's the Python script, which is as simple as every other cross-validation techniques to implement. Well, now we have time series cross-validation technique. For time-independent data like stock prices or weather data, we use time series cross-validation. It works by presenting the sequential order of data, that is, training the model on earlier data and validating it on the later data. This technique mimics the real world scenario where we want to predict future values based on the past information. It is essential for time series forecast problems. This is also very simple to implement in Python and you can see it on the screen. Here's a summary of the techniques we have discussed today. Each method has its own pros and cons. Leave one out, cross-validation gives us maximum data for training but can be slow. K-fold and stratified K-fold are versatile and widely used. Hold out is quick but may not always be reliable. Time series cross-validation is critical for sequential data. Understanding the strengths and weakness of each method helps you choose the right technique for your dataset and model. To wrap up, cross-validation is a vital technique in machine learning that ensures your model generalizes well to unseen data. The choice of cross-validation method depends on your dataset and the problem you are trying to solve. By selecting the right technique, you can avoid overfitting and ensure your model performs reliably on new data.
So that's it for today's video. In case if you have liked this video, do like, share and subscribe to my channel Learn with Simran. Thank you so much for watching. Keep learning. Bye bye.